Technology is the foundation upon which our society is built. Everyone has a smartphone in their back pocket, and we are connected by a seemingly limitless grid of energy. However, this world we've built for ourselves comes at a cost, and that cost is a lot of fuel. For decades, we've relied on carbon-heavy, non-renewable sources of energy, such as coal, oil, and gas, in an uneasy relationship that will have catastrophic consequences. The questions we need to ask ourselves are, what are the impacts of our fuel use, and what will happen when it all runs out? It's hard to forget the problem of the century, climate change. Carbon-heavy fossil fuels produce harmful greenhouse gases that trap solar emissions, warming the Earth. This man-made issue leads to the melting of the polar ice caps, rising sea levels, and more extreme weather patterns. Carbon dioxide also directly causes many issues, such as acid rain and ocean acidification, when it dissolves in water to release carbonic acid. Now, New Zealand is no innocent bystander in all this, pumping an astounding 80 million tonnes of greenhouse gases into the air every year. While our energy sector is not the sole contributor to this, it is not innocent. Carbon dioxide is a major product in the combustion of fossil fuels, and so new sources of energy must be found that don't have an impact on our carbon footprint. But what happens when the fuel runs out? Coal, oil, and gas are non-renewable, as they will eventually come to an end. With accelerated energy use, it may only be 100 years before we no longer have access to these valuable resources. In 2013, 62% of New Zealand's total primary energy supply came from non-renewable sources such as coal, oil, and gas. Imagine, if only 38% of New Zealand homes and businesses had electricity, if only 32% of people who needed life support had access to it. We need to find new sources of energy that don't rely on these unreliable fuels. The bottom line is this: fossil fuels are bad. They destroy our environment and they won't last forever. Ladies and gentlemen, I invite you to look into the night sky for a solution to our problems, because up there, you will see trillions and trillions of stars utilizing a method of energy production almost as old as the universe itself. Fusion power, the stellar solution to the energy crisis. But how does it work? Fusion technology works by fusing two smaller particles into larger particles. A product of this reaction is a small amount of energy, which when conducted on a massive scale could be an efficient power source. Unfortunately, it's not quite as simple as this, as fusion requires extreme temperatures, akin to those at the center of the sun. This can be achieved by surrounding the reaction's components in ionized plasma at millions of degrees Celsius, contained by a complex magnetic field in a torus shape. But if it's so perfect, why isn't it being used today? Unfortunately, the devil is in the details. Configuring a complicated system of magnets around scorching hot plasma around our gaseous fuel without solid containers is a bit of a mathematical and scientific challenge. Current methods are very inefficient, with more power going in than what's coming out. I can't stand here today proposing that we build a nuclear fusion reactor in Wellington tomorrow, but only encourage greater New Zealand research and investment in this monumental field of the future. With greater economic and scientific interest, we will perfect this technology and see it solve our rising issues. But how? Firstly, it's carbon neutral. Fusion power produces no greenhouse gases, compared to the 33 million tonnes coming out of our energy sector annually. While not cutting our contributions completely, it is a step in the right direction. Worldwide, the adoption of fusion power could mean cutting up to a third of our global carbon emissions, which, as one Kiwi legend once so eloquently put, is better for all of us. Secondly, it's not going to run out. Deuterium, a common fuel for fusion power, occurs 1 in every 6,000 water molecules. It is a higher boiling point than regular water, meaning that it can be distilled from its lighter counterpart in a common lab. Since it does use this fuel, it is technically non-renewable. However, our estimates indicate that deuterium supplies on Earth could power the whole world for 150 billion years. For some context, that's over 10 times the estimated age of the universe, I think we'll be okay. Replacing fossil fuels with this expendable energy source removes the worry of having to adapt, removes the worry of having to make serious changes to our infrastructure as the amount of energy worldwide dwindles. At this point, I feel it's necessary to distinguish fusion, or thermonuclear fusion, to use its full name, from the nuclear power we all know and fear. Fusion is a fundamentally different process to nuclear fission, where a heavy radioactive nucleus is chaotically bombarded with neutrons until it splits into two smaller nuclei. In New Zealand, concerns about radiation, disasters, and weaponry have led to a complete taboo of even the word nuclear. So let's clear the air. Radiation. While fission reactors produce radioactive materials with horrible sounding names like xenon and krypton, fusion reactors produce alpha particles. Fission waste is highly dangerous, causes horrific cancers, and can take up to 1,000 years in underground contamination tanks to reach safe levels. The structural pieces of a fission reactor can take even longer than this, since they are exposed to such intense radiation for such a long period of time. By comparison, alpha particles can't penetrate the skin, rendering them relatively harmless to us. And similarly, the structural pieces of a fusion reactor can take less than 50 years once contaminated to reach safe levels, even less so if we utilize radiation-resistant materials such as carbon fiber. Fusion power poses no threat to us here. Disasters. Chernobyl and the Fukushima meltdown were horrific events that brought attention to the dangers of nuclear fission. If something goes wrong, all that radiation spills out into the world to devastating effect. However, with nuclear fusion, if something were to go wrong, then the entire system would almost instantaneously cool down. Without these extreme temperatures, fusion cannot take place and the reactor stops functioning. No explosions, no radiation, no danger. Weaponry. While it is true that the dreaded hydrogen bomb does utilize fusion reactions, it does this by adding fusion fuel, which as we've seen can already be distilled from regular water, and adding this to an already dangerous fission bomb, using the heat of the explosion to generate fusion. Our development into fusion technology will seek to find new ways of achieving fusion, thus having no use to any nefarious minds with their mindset on nuclear weapons. It's also worth noting that replacing the global market for nuclear fission with nuclear fusion would mean there would be less mining of dangerous radioactive fission materials. We could rest a little easier knowing we've minimized the risk of nuclear terror attacks and made the world a little safer. While the concerns of many New Zealanders regarding current nuclear power aren't unfounded, we're talking about something completely different. Something that poses no threat to New Zealanders or the beautiful country we call home. I hope that this has helped avoid confusion. But we're not here to talk about the problems this technology doesn't have, rather the economic, environmental, and social benefits that it will bring. Economically, the locations of fusion plants would target areas of New Zealand where, for geographic reasons, farming, mining, and other industries just aren't ideal, and this has led to a number of socio-economic problems. We would also be protecting our primary sector from environmental concerns. Ocean acidification destroys marine environments. And as a country that brings in $1.2 billion every year from fishing, we will feel the blow. Similarly, climate change increases the frequency of extreme weather patterns, such as storms and droughts. In a particularly bad year, New Zealand can lose up to $3 billion from drought alone. Cutting carbon emissions is an economic interest in New Zealand, and fusion power is a step towards this. Finally, fusion power is more cost-efficient than its fossil fuel counterparts, lowering power bills everywhere. Now, I know that's a lot to take in, so to better visualize this, let's take the example of Northland. Northland has New Zealand's highest rate of unemployment, contributing just 2% to our national GDP. Northland also houses New Zealand's last oil refinery at Moa Point, with most of the oil coming in being imported from the Middle East. Imagine redesigning this industrial area as a fusion reactor. We would be providing cheap, renewable power to the nearby metropolis of Auckland, creating construction and maintenance jobs in a poverty-stricken area. reducing imports of one of the world's most expensive natural resources, and minimizing the risk of natural disasters by cutting our contributions to climate change. And that sounds like a good idea to me. Environmentally, fusion power is superior to many other sources of energy. Fusion power produces no greenhouse gases, so there's no detrimental effect on the environment. Replacing fossil fuel with fusion power would see the return of many flourishing ecosystems, a key benefit to any clean, green nation such as ours. And worldwide, the adoption of fusion power would be better for all of us. Socially, we would see more jobs being created in low socioeconomic areas, which would raise the standard of living for many New Zealanders. This would have a number of far-reaching effects, from better health and better education to decreasing poverty. We would also be replacing current nuclear and coal plants, industries with potential for massive loss of life, with a safe alternative. We would also replacing these industries, we would be cutting back on our contributions to climate change. We would be leaving behind a world for generations to come to enjoy just as we do. So let's live by the philosophy of taking only photos, leaving only footprints. Our future is a serious concern. We have the power to destroy our world or save it. All I ask is that you take a step back, look into the night, and see the answer shining back at you. Thank you.
Thanks, Finn. So what you're saying is if New Zealand can build a fusion plant, everything would be better.
I think a lot of things would be better, yeah.
So what are you offering in terms of answering the problems that have defied fusion power for some 6 decades?
Well, the biggest problem with fusion power is a lack of interest from governments and also from private companies. So there are a number of projects around the world, but one of the things they're really struggling with is finding funding.
So what do you think more interest would do in, for example, answering the challenge of maintaining temperature?
Right. Well, probably the most advanced reactor in the world is the European ITER, and they're building a current one which will be 50 times more efficient than any previous ones.
And what makes you think New Zealand can compete on that level?
I don't think it's really a question about competition. I think this is a worldwide issue, and we really need to be collaborating with these other projects, to be sending over our best and brightest scientists, and to be sending over money to help these projects really get off the ground.
We need to send them money?
Money and scientists, to really have a stake in this global market.
One last question. On your pie chart, you had something called stationary energy. What is that?
Stationary energy, as I understand it, is energy that's being housed, but is still somehow by being housed, contributing, like it's somehow emitting, or in the process of housing this energy for later use, is still producing carbon emissions.
Okay.
I think.
Thank you.